Hello YouTube, RJ. Today we're going to be building a kit by a ham radio operator, KC90N. He runs Third Planet Solar, and he likes to do fox hunting apparently, and he has created a offset attenuator for fox hunting. Now the backstory is this: the hams in the local ham club who's convinced me that fox hunting is a lot of fun, and I just have to try this. So I've broke down and decided to make the commitment to do that. So I want to build a couple pieces of equipment to make that happen. So I'm going to be doing videos on the different pieces of equipment I build, probably the first fox hunt, to see just how horrible I can be at it. Should be good for a couple laughs anyway. But basically what a offset attenuator does is, for those that are not aware, you have a directional antenna, typically a Yagi, that you're using to get your bearings to the fox, the hidden transmitter. I guess I should explain. A fox hunt is when hams hide a transmitter out in the woods, in a park, somewhere. They have all the people that want to compete in it. They give them the frequency, and then you have to take a directional heading to it and make a couple cross bearings to it and work your way in and find this thing. Often it's like buried in brush. I mean, it's really hidden. They tie them in the tops of trees. They paint them camouflage. They do all kind of things to hide them. It requires you to be able to get right down onto it. In fact, they say commonly the hardest part of the hunt gets right down to the last 100 feet. It really could be a challenge, I guess. A directional antenna will get you pointed in the right direction, but the problem with that is as you get closer to the transmitter, your signal strength is going to get so strong that you're going to be full strength no matter where you point the antenna, so you can't take a bearing. Because of that, you need a way to reduce the strength of the signal. So that's what this device does. And what it does, it's really just a mixer. Like for when we've looked at talking about mixers in previous videos for RF radios, where you bring in a signal and you put a LO, local oscillator signal in, and they blend together and give you the plus and negative of the two signals out. So what this does, it uses a little 4 megahertz crystal, and it generates a 4 megahertz signal that it blends with incoming antenna signals and shifts them 4 megahertz. So what you do is, as you get closer in, it's an attenuator. It's already an attenuator. So you start attenuating the signal down, but when you get so close that maybe you're a mile away and you can no longer attenuate anymore that way, what you do is you switch this on, turn your attenuator back all the way off, turn this on, tune 4 megahertz up or down on your radio, and the signal drops off. As you then can turn the knob, start all over again, attenuating more and more and more. And where it really helps is when you get real close to your transmitter trying to find it, the signal can leak in the case of your radio if you're on the primary frequency. So by shifting 4 megahertz off, that can't happen. Anything you receive in your radio at that 4 megahertz off center frequency has to come from this attenuator, because the transmitter that you're hunting isn't putting that frequency out. So it really lets you get right down on it, your antenna, and crank the attenuation way up there so you can keep having a directional antenna right up to the item. That's what it's for. We're fixing to build one from this kit. The circuit's not complicated. I thought about building one myself, but because the next hunt's coming up pretty quickly, I just didn't have time to have a circuit board made such. So when I looked at this one, it was like $10 for the kit. It was a no-brainer. So I've ordered this kit. We're going to build it. So let's take a look at what we have, okay? Right off the bat, I can tell you looks like it might be a little easier to work with than the kit we built previously from Kits and Parts, simply because they've separated and bagged everything out so nicely. It's very nicely done. Should not be that hard of a kit. It's a simpler kit to start with, I think. It's all through hole. Everything's labeled out, so it looks like it will be such a nicer kit to work with just because of that. But a lot of that has to do with the other kit with surface mount, and it's really hard to separate every surface mount item out. As we can see here, let me get this out of the bag. It's a really small circuit board, not big at all, which is nice because I wanted a good metal case to shield any RF from getting to this board directly and not coming in the coax. So because of that, I've purchased this cast Yeah, I guess I probably ought to look at it under this camera. Move some parts around here. I bought a die-cast little box, seriously aluminum die-cast from Amazon. It's, as you can see, it's very well sealed. Got an O-ring sealing with lip. And the idea is we're going to put this in here with two BNCs coming out and the potentiometer coming out to control and the switch. And this way, nothing's going to get into it. With the BNCs being grounded straight to this, the whole case will be grounded. We won't be able to get any RF in here unless it's coming in off of the antenna. And so that's my intention. So that's what we're up to. Let's get on this build. So the instructions, just like with the previous kits and parts, is on the web. Here it is. Talks a little about using about fox hunting with it. Looks like we don't need a whole lot with this. Here's our parts list, and basically we'll start the build. Looks like the first thing we're going to be working with is R4. R4 is a 4.7K, so we're going to go here and take out our 4.7K resistor from these. I guess the best thing to do is cut it. So there's our 4.K. This will be a straightforward build. I'll put a couple parts in and jump ahead, and anything that's anything that I think you need to see, I'll make sure that gets in the video. And so there's R4. We're going to put R4 in. Obviously it's resistor. Doesn't matter which way it goes in. Should have been it before I put it in there, but that's okay. We're going to get R4 in here. There's R4. Get our clippers. Clip off a little of this. Clip a little of that off. Let's get our soldering iron clean. Let's get R4 installed. Okay, there's R4. Now, get here where you can see what I'm doing. We're going to clip him off as close as we can get. Okay, one resistor in. C3 is our next one. C3 is 220. So that's going to be this one right here. C3 and C4 is right there. So let's drop them in. C3. Open my leads a little to keep them in there. Let's go ahead and solder them. Let's trim them rascals off. Those are done. Now, problem is I've got that 220 puff capacitor. One more left somewhere. Where's that going? Right here, C2. We're going to go ahead and put that in now so it doesn't get lost, because that's what's going to, it's going to get lost if we don't. Go ahead and do him. So let's get him in. Okay. So all three of those are in now. Don't know why we didn't just go ahead and do that in the instructions, but okay, so those are done. The next is the diode D2, which is this diode right here, the mixing diode. Its job is to mix these frequencies, the 4 megahertz we're going to generate on this board and the incoming antenna frequencies, so we can push the antenna frequencies 4 megahertz up and down. And if you want to understand that a little better, you haven't seen it, watch my video called Can We MacGyver a Radio Off of Junk on the Bench, where I explain how tuning works in a radio, and that will explain how this mixing stuff works with a diode. Mini mixers are nothing but diodes. In this case, that's exactly what this is. And so let's find our D1. D1 is right, I don't think that's, oh, we're looking for D2, I'm sorry, so that looks like an LED. D2 is right there, and notice very closely that there's a band on one end, an extra line, a little thicker line right there. And if we bring our diode in, you'll see there's a band on here. Very critical that we get that pointed the right way. Diodes aren't like resistors. They're not bidirectional, they're unidirectional. They don't work the same way going in different directions. So we want to make sure, as you can see I've done here, you want to make sure to get the band in the location of where the band on the board is so that we have the right polarity. Okay, now we need to put our transistor in. So J113 transistor is right here. Need to make sure that we get it in proper. If you look, there's a flat on the Q1, which Q for the transistor right here. Notice that there's a flat side. Notice that there is also a flat side to the transistor. So we need to go in this way, which means the middle lead is going to have to come out a little bit to get in. So it'll go in. And then we'll take it right down to the stops. I've got another resistor to put on. I'll go ahead and slap that on. That's the 2.2 and R5, and I'll be back. Okay, with that, R5 was installed, but also there was two 2.2K resistors in that bag when I opened it. I went ahead and looked it up, and this is the other one. It was R2. I went ahead and took care of both of them, because once you open the bag and those resistors are out, things are going to get confused if you keep opening bags. And it's hard to, you have to take time, look at bands or measure the resistance and stuff. And from doing mini builds and kits and things over the years, I've learned that it's best not to do that. That's why when I do any kitting in the old days, I used to always make sure that my instructions, if I opened a bag that had this resistor and this resistor the same size, then I went ahead and said, install this and this right then. And got them in, got them locked down. That's a very minor thing I could say about the kit. The kit looks very good so far, but that's one thing I would say is the instructions, you should open a part and put all of them in unless there's absolutely a reason why we can't do that. So we've got that in. The next thing to do, there's a 20K pot to put in. Oh, here it is. Here it is. My part's right here. RV2 is right there. So we're no problem figuring out how to put this in. As you can see, the 3 pins are shaped in such a way it would only go in one way. It will go in and so far and basically lock in. So that's done. Now let me get my little screwdriver here, and we will find halfway to there. So we're going to be about halfway, right about in there, I would say. So we'll go with that. And let's see, what does it want us to do now? So those two resistors have been added. That was our 1 meg, 1K. Now it wants me to put the crystal in. We've got our crystal, 4 megahertz crystal in now. Let's see what's next. All right, C1's in. What's next? It's talking about putting these terminal blocks on. But I'm not going to do that. And the reason is, I'm putting this in a case. I'm going to use BNC connectors. I'm going to wire straight to it. So they're talking about all these connectors. Like here, the J2 and 3. This is for your antenna in and your radio out. Or your radio to your radio. From your antenna to your radio. I'm going to do direct coax from this to the BNC. So we're not going to put those on at the moment. The potentiometer goes here. So they're looking to put this potentiometer on the board. But I don't want to do that either because I'm going to feed the potentiometer into the case, and I'm not sure where out, but out somewhere to control it while it's sealed. So I'm not going to be doing that. So that's a no-go. But there's an LED, and it's talking about the LED and what to do with the LED. I will put the LED on. You never know when a circuit might really need something that it's calling for. So I'll go ahead and put the LED on. That's the last thing I can do at this point, is put the LED on. It's going to go right here, D1. So I'm going to think about that a little bit. Decide what I want to do. Make sure you get the polarity right. There's a little flat spot on the LED if you're wondering. It's a little, let me see if I can get where you can see it. Can you see the little flat spot here in the camera? You look at the diagram on the board, it shows you a flat spot. And that's just the way she goes in. So I'm going to go ahead and put this LED on. The board, I'm not going to have it coming out of the case. It's just going to be, it's going to take away from my waterproofing. You know, I've got a really nice waterproof box. Let's keep things watertight, if we will. But I'm not going to leave it off either. You know, you say, well, won't drain the battery as fast. Well, that might not be the case, but I don't think the LED is the high draw on this board. So anyway, there we are, our LED's on. So at this point, really, I'm kind of ready to look at mounting, hooking up a battery, getting everything hooked up, and then testing. So I'll come back. Okay, we're back, and I've relocated the cameras a little bit here. So I went ahead and, as you can see, I wired up the switch to the battery, and I put the potentiometer, but with some leads because it's going to go over to my box. And the testing part of it says, take your oscilloscope if you have one, turn the potentiometer all the way clockwise, which I've got it all the way clockwise, and it says turn it on. You should see the LED. Okay, LED's not real bright, but I can see it. I don't know how that's showing up. It says go to the outer side of J2 or J3, either one, and you should see a 4 megahertz signal. And I've got a sine. There's a sine wave coming out. Let's hopefully you can see that decent. We've got a fairly clean looking sine. I'm not 50 ohms. Probably if I was to put my 50 ohm termination on there, that'd be a lot cleaner looking. 4.00051 megahertz according to the scope, the oscilloscope. So I would say that's our animal, and I assume this turns that down. Oh yeah. So this controls the level of that, and that's what controls how much mixing takes place and how much of the signal gets through. So looks like we're working. Just going to mount it in the box. I've got some BNCs to hook up, which might be a challenge, but we'll get it. We'll be back. Well, we're back on the offset attenuator, and I've got it completed. I mounted it in its box. I've got one of the screws. I got a screw here in the corner over here onto the fittings, the bosses in the box. So it's mounted secure. Got the switch mounted through. Got the potentiometer mounted through over here and wired up. 3D printed a 9-volt battery clip. Brought the battery wires out. I still have to put a little silicone on the hole where the wires come through here to make sure keep it waterproof. This is really tight, doesn't move around, but pops off, lets me put a new battery on when I need to without opening everything up. So really happy with the build, really happy how it come out. There was enough metal on the bottom that I was able to drill and tap threads into that screws come through the antenna boom and bolted on here, so it's fixed on. Real happy with how this is going. You can see that, maybe you can see the, yeah, you can see the LED coming on and off. So we're working, we believe. So now we're going to test it and find out and take a look at how it works. So I've got it hooked up to my signal generator coming in here, set up for minus 10 dBm signal coming in at 60 megahertz. That's the max frequency my signal generator will do. So I went to the max. Got the output going into the spectrum analyzer. So let's click on the signal here and see what we have. Okay. Now you see the signal there. It's it's 37 dBm, but we're putting minus 10 dBm, and it's getting minus 37 dBm, 36. Well, that's because this is off. You operate with this on. Otherwise, it becomes a massive attenuator because it's just off. So anyway, now we're looking at it, and you can see we're still down about 6 dBm, which that's true. It does act as an attenuator even when it's all the way down. So you do have losses through here, but that won't be a problem because we've got a big, directional antenna here. It's going to give us some boost. You could always connect the two cables together if you really needed that signal to begin with. If I'll carry a coupler just in case I need to do that. If the signal's kind of weak at the beginning of the fox hunt, there's ways you could have done some work in here to have a switch to bypass, but I didn't do that. I don't think I'm going to need it. But anyway, as you can see, when you turn it on, when it's off, you've got the main signal at 60. Let me do a peek here. At 60 megahertz, at 37.31 decibels. When I turn it on, more of the signal gets through. I get up to minus 16, so I'm taking about a 6 dB loss from the signal coming in. But notice that we have two peaks here and here. Well, if I move the peak right, you'll notice that's 64. And if I move peak left, that's 56. So it's 4 megahertz offset, which is exactly what this is supposed to do. So these signals are your 4 megahertz offsets. The idea is you start your hunt on frequency. So you start with your radio set to the frequency of the fox, and you start narrowing, getting closer. And as you do, and the signal gets too strong, then what you do is you switch over to 4 megahertz up or down. That gives you quite an attenuation off the bat. You can see here we're looking at, let me do this, we're looking at 16, and we're looking at 36. So you're talking a 20 dB attenuation just switching to that frequency. You get a 20 dB drop right there. But then you have the attenuation knob. So notice that if I start turning this, I can take them signals all the way down into the noise. And so that gives me, the benefit that it gives me is not the ability to attenuate very high attenuations, but it also stops the problem in fox hunting where your handheld actually starts picking up the signal directly. If you attenuate your antenna too much, then the signal just would rather go through the case of the radio. So you still get a signal and you can't attenuate it no matter how much attenuation you turn on. But with an offset, once you move over this frequency, tuning the radio to this frequency, and no longer can it receive the signal from the fox, so it can't come through the handheld and get it. It has to pick everything through the offset attenuator from your antenna. So that allows you to just crank that right down in the noise if you want to. So you can literally get it to where you can walk right up to the fox, and you can attenuate it to where you have to be right on top of the fox, pointing right at it to get a signal. And that's what lets you narrow down the location to get what you want. So that's how it works. Seems to be working well. Pop the top on and we're done. So that's it for this. That's the offset attenuator. Neat kit. Well done. Works well. Can't wait to use it on a fox hunt. Next video you'll see out of this series is we're going to build this antenna. It's not very complicated. We'll walk you through how we designed the antenna, how I built the antenna. With this combination, you'll have a little Yagi antenna designed optimally for fox hunting, and handy antenna that'll come apart. So see you in the next video. Thanks for tuning into this one.